My name is Xiaohan Yu, and this is Math 133 video project session 25. So the first question is, approximate exponent power of x sine x using three terms in Maclaurin series. So as we learned in chapter 11, Maclaurin series is like this, like fx plus first degree divided by 1 fractional times x plus second degree divided by 2 fractional times x squared plus third degree divided by 3 fractional times x cubed, and so on. So the first step, we need to find out variable that we don't know, like fx, first degree, second degree, and third degree. So the first one, we put the x equals 0 into the fx, like the equation will be like exponent power of 0 sine 0, and the answer is 0. And the second one, to find the first degree. So first we need to find out the equation. So we use the product rule. As we know, the product rule is like d divided by dx times uv equal to u times dv by dx plus v times du by dx. So after we calculate the equation, the function of the first degree is like exponent power of x sine x plus exponent power of x cos x. So then we put x equals 0 into the function, like exponent power of 0 sine 0 plus exponent power of 0 cos 0, then equal to 1. Then go to the next one, the second degree, same as the first one. Find out the product, find out the equation, use the product rule, like 2 times exponent power of x cos x. Then put x equals 0 into the function, like 2 times exponent power of 0 cos 0, and which equal to 2. The last one of the first step, just find out the function of third degree first, and put x equals 0 into the function. Like the function of the third degree is 2 times exponent power of x cos x minus 2 times exponent power of x sine x. Then put x equals 0 into the third degree, like 2 times exponent power of 0 cos 0 minus 2 times exponent power of 0 sine 0, and which equal to 2. And right now we know each variable that we want to know, and put all this number into the function. Like we go to the step 2 part of series. So the function will be like 0 plus 1 divided by 1 fractional times x plus 2 divided by 2 times x squared plus 2 divided by 6 times x cubed, and so on. And since we learned that the first term couldn't be 0, so the series like includes 3 terms in Maclaurin series is like fx equals x plus x squared plus 1/3 x cubed. So this one is our final answer. So second question is the true false question. The question is like, approximate fx equal x power of 1/3 by a Taylor polynomial of degree 2 at a equal 8. Then this approximation is accurate to within 0.00001 when x in the interval 7 to 9. So first step, we need to list out the function of each degree. Like since it's degree 2 at a equal to 8, so we need to list to the third degree, and which the function is useful next. Like the third degree functional is 10 divided by 27 times x power of negative a third. Then, as we learn in chapter 11, Taylor's inequalities, we learn the function like absolute R2x equal to m divided by 3 fractional times absolute x minus 0's power of 3. So we need to find out the m, and the m should be larger or equal to the absolute third degree. So go to here. This part is how to find m. So first we know x should be in the interval 7 to 9. And as we know, the function like x minus a, which is here, this part should be less or equal to d, and d which is equal to 1. And as the question we load a equal to 8. So x minus a absolute should be less or equal to 1. And we load here like m is larger or equal to the function of third degree. So here is our function of m. Then we put x equals 7 or x equals 9 into the m to find out the number of each part. Like when x equals 7, m equals 2.066 times 10 power of negative 3. And when x equals 9, m equals 1.056 times 10 power of negative 3. So compare these two numbers. We know at x equals 7, m has the maximum value. Then we can reload m, and below here is 0. So we put all below into the function absolute r2x, and which is 10 divided by 27 times 7's power of a third times 1 power of 3 divided by 3 fractional, and which is equal to 3.44 times 10 power of negative 4. And approximately this number is equal to 0.0003. So, which is difference with the number that question given us, 0.0001. So below, the answer of this question is false, since the approximation is accurate to 0.0003 but not 0.0001. Thanks for watching, and this is my video project. Thanks.